All right, now I want to talk to you about what is a vector and what is a scalar. So a scalar only has magnitude. It's just going to be a number. So for example, speed is going to be a scalar. On your car, you have a speedometer, and your speedometer is going to say that, let's say you're going at 30 miles per hour, or let's say that you're going at 20 kilometers per hour. So it doesn't tell you what direction you're going in. It's just telling you that that is your speed. So speed is a scalar. Now, let's say somehow that you had a speedometer that also had a built-in compass. So not only is it telling you that you're going at 30 miles per hour, but it says you're going 30 miles per hour north. Well, in that case, that's going to be your velocity. So velocity is going to be a vector. It has both magnitude and it has a certain direction. Another example of a scalar is time. So if you look at your wristwatch and it says that it's 3 o'clock, it doesn't say 3 o'clock to the west. It just says it's 3 o'clock. So that's going to be a scalar. Mass is a scalar. So something that has a mass of 1 kilogram, well, it's 1 kilogram, not 1 kilogram north, not 1 kilogram south. Energy is another scalar. Electric charge is another scalar, and temperature is a scalar. But your position, so if you're saying that you're making a certain measurement and it has a certain length, well, you could also specify the direction that the thing is going in. So that is going to be a vector. Velocity is a vector. Acceleration is a vector. A force, a push or a pull, that's a force, is a vector. Momentum, and so are fields, like a magnetic field or electric field or gravitational field. So all of those are going to be vectors. Now, what does this have to do with geometry? A vector can be recognized as an arrow. So the length of the arrow is going to tell you the magnitude. So let's say that if this arrow represents 10 newtons of force, then how should I draw it if it represents 5 newtons of force? Well, I would make it pointing in the same direction, but I would only make it half as long. So twice the length of the arrow means twice the quantity of it. And then notice that the arrow needs to be pointing in a certain direction. So a vector is going to be, you can draw a vector as an arrow. The length of the arrow is going to tell you something about how big the vector is, and then the arrow is going to be pointing in a certain direction. So the question is, how are we going to add arrows? How are we going to add vectors? So my first example here is going to be if the two arrows are parallel to each other, how do we do it? And so to help me to do this, I have a simulation here, and it's from PHET, so P-H-E-T. So if you will go to the internet and then go to PHET, P-H-E-T, and then this one is entitled Vector Addition. Okay, so did you find it? And so first we're going to explore one-dimensional vector addition. So if we click on this, we get this. Now we can go over here and we can grab an arrow and we can put it there, and then we can grab another arrow and then we could put it there. Okay, now what was something that we could change about a vector was its length, so that if you grab it by the head, then you can make it as large as you want. So I'm going to make it so that it's 3 units going this way. And then I'm going to add it to this arrow right here. So what are we going to get? So what do you think you're going to get when you add an arrow that's 3 units long plus an arrow that is 1 unit long? What do you get? Okay, so I'm going to go over here and click on this button up here which says sum, and you see this blue line here. So this blue line is 1, 2, 3, 4 units long. So 3 plus 1 makes 4. That's pretty easy. But what about if one of the arrows was pointing in the opposite direction? So let me get rid of the sum. And then what I'm going to do is I need to reverse this one. So I'm going to move it so now it's going backwards. And notice it's still going to be 1 unit long, but is pointing in the opposite direction, so it's negative. So do you remember that when you graph, you had the 4 quadrants, and so anything that was going to the right was a positive x, and then anything that was going up was a positive y, and then over here this was a negative x, and then this was a negative y. So we're going to use that same sign convention. Anything to the right is going to be a positive number, anything to the left is going to be negative, anything up is going to be positive, and then anything pointing down is going to be a negative number. So this one here is going to be a negative 1, and we're going to add it to a positive 3. So what do you think you're going to get? Okay, made a prediction. So now we're going to go over here and we're going to click on the sum. And notice this time our blue line, the dark blue line, is not as long as it was before, because this time you're subtracting. So now you can go over here, and as long as you grab it in the middle, you can move it around. Don't grab it on the end, because that will make it longer when you do it. But if you grab it in the middle, I'm going to put it over here so that this blue line goes to the side 3, and then it goes back 1. So then 3 minus 1 is going to be 2. And then notice that if I go from here over to here, that's going to be 2. And it's if I go from here over to here. I think I could even grab I can grab this one and I could put it down here so that you can see how they added up. So when you're adding arrows and they're in the same plane, then it's really easy. It's just algebra. So that remember that anything to the right is a positive number, anything to the left is negative, and you just add those numbers together. Okay, so that finishes adding arrows together when they are parallel to each other. But now it gets more complicated though if they are not parallel to each other. So now what we're going to do is go down to here and click on this one, and now it's going to be in 2 dimensions. So we're going to have 2 arrows, and we're going to add those 2 arrows together. And what we could do is I'll make one of these arrows long and then one of the arrows small, and then if you grab it by the head, not only can you change the length, but you can change the angle. If you grab it in the middle, all you're going to do is slide it around. But if you want to change its length or change the angle, you have to grab it by the head. And what I'd like to know is if I added this arrow to this arrow, what would be the new arrow that I would generate? What would be the sum of those 2 arrows? You can't just add the numbers together. So this one is obviously a 2, and then this one up here looks like it's about a 3. So you can't just say 2 plus 3 makes 5. So that's not going to work. So this is the reason why I introduced this concept in geometry, because we're going to geometrically add these two arrows together. And the way that we're going to do it is we're going to add them head to tail. So every arrow is always going to have a tail, and then every arrow is always going to have a head. So this is a tail, and then this is a head, and we're going to add them head to tail. So I'm going to grab this one, I'm going to put it over here so that the tail of this one is at the head of this one. I like to think of it like a conga line. Dun 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 dun. So it's going to be head to tail. You don't have to know the song. And then we're going to do the same thing. We're going to sum them, and I get the blue line, but notice this time the blue line is not flat like it was before. It's tilting. And now, how could I take this blue line and put it on this so that everything matches up? Okay, can you see that if I would take this blue line and I put it over here like this, do you see that if you start with the tail of your very first arrow and then connect it to the head of the very last arrow, then you get this line right here, and that is the sum of these two arrows. You could even, if you grab it here, I could change the angle and I could change the length of that very last arrow and see how the blue one automatically goes with it, so that you can see that it's always, when you add this arrow and this arrow, you get this arrow. Now there's nothing magical about adding the tail of this arrow to the head, or the head of this one to the tail of this one, because if I wanted to, I could take this one and put it like that. So notice I reversed the direction of these two arrows, but look at what happens to the blue one. So the blue one there is the same as it was before. So it doesn't make any difference the order in which you put the arrows. What does matter is head to tail. You always have to put the arrows head to tail, and then your final arrow has to be the tail of the very first arrow and then connect it to the head of the very last one. So notice that I could grab another one and put it in there like this. Now, did you notice that this one changed shape? Why do you suppose? Because I could take this one. Now it has, so here's the tail, and the tail has to go at the head of this last one. So I'll grab this one and I'll put it over here, and then notice that if I start with the tail of the very first one and I attach it to the head of the very last one, then I get this blue one. So that is going to be vector addition when you have things that are not in a plane with each other. So when it's two-dimensional, you have to use this particular method. Okay, so here is an example of how to add two arrows together when they're in the same plane. And then the next one is an example of what do you do when they're not parallel to each other. So here's again that blue line, and it's going to be going from the tail of the first one to the head of the last one there. And then here's an example of how to do this. So now notice that in this picture up here, the two arrows are not head to tail. They're actually tail to tail. So you cannot just draw a line from here down to here. So that would be incorrect. So over here, you see I redrew this line horizontal, so I made sure it was the same length and it was horizontal. Same length, same angle. And then this one is this one here, same length, same angle, and then I connect them, and then that is going to be my answer. All right, let's take one more break, and when we come back, let's talk about measuring angles.